Do numbers, constants u of x0 matter in potential energy functions?
Not really.
No, they don't, right? Potential energy, only thing that matters in potential energy function is differences in potential energy. So additive constants never matter, which is why when you drop an object, you can set the floor to be the place where h is equal to 0, or the ground outside the place where h equals 0, the ceiling place where u is equal to 0, right? So additive constants don't matter. So this this term over here we just don't care about. And what we're left with, though, then, is u of x is approximately 1/2 k x minus x0 squared near x0. And now we all jump up and down because we've discovered that in the region of our minima of our potential energy function, that our potential energy looks like a simple harmonic oscillator. All right. Spring would be fine too. Spring is perfectly fine. All right, so it looks like a simple harmonic oscillator, but which is spring is the most standard example. Okay, so any potential energy function, no matter what the physics that sets it up is, it doesn't matter if it's some wacky other thing. It's not a physical spring. Whatever it is, if it has a minima in its potential energy function, near the minima, the physics is identical to the physics of a spring. Which means if you understand the physics of a spring, you understand a wide variety of situations where you can apply it. So this is the locus of this joke, right? That once you understand the spring really well, which we're going to do for the next week now doing, then anytime you run into a potential energy function which has a minima near that minimum, that physics you already understand. Yeah.
What happens to the higher order terms?
Well, they're small, right? So this is why I keep saying the word near the minimum of the potential energy. So near x minus x0. I would have another term here that would be plus x minus x0 cubed. So as long as x minus x0 is small, as long as I'm near the minimum, then I can ignore all those higher order terms, and it's dominated by the spring potential. Yeah, so in a given physical situation, you'd have a perturbed harmonic oscillator. And then you can think of this as the basic physics is driven by the spring harmonic oscillator physics, and then but it's different by this amount, and then in a given situation you might want to explore that. Okay. So let me hand out the activity. 2 pages. Did those not work right? Yes.
You were closer. I thought your color. You haven't been collecting anything.
I haven't collected anything. I probably should collect your notebooks. Sometime soon.
That would be good.
Within the next 2 weeks, before the next exam, I will collect notebooks.
Well, we
Get your shit in order.
Will we have our notebooks back for the question?
Yeah.
Okay.
So maybe what we'll do is, during the next exam, you will pile up your notebook, and I will look at them and hand them back to you.
Okay.
That's what I do. So during the next exam, you need to have your shit in order.
When you said our next exam is,
3 weeks,
so including this week or 3 weeks from today?
including this week. So 3 more classes, including today. Alright, so problem 1 is, this straightforward thing, you can do it. The idea is that if your situation looks like a spring, you can always make it become a spring. So spring forces, right? Spring potential energies look like 1/2 k delta x squared. Spring force looks like minus k delta x. All right, so just do number 1. Good.
Quick lecture.
7 minutes.